Hello everyone, this is Professor Abolghasem from Department of Computer Science and Engineering at Sejong University. It is a pleasure to have you here for this in-depth section on one of most elegant and intuitive Python library for data visualization, Seaborn. In today's data-driven world, clear and attractive visualization is crucial, not just for analysis, but also for insightful storytelling and impactful communication. Seaborn is built on top of Matplotlib and designed to simplify the creation of the statistical visualization, helping you understand trend and distribution and relationship in your dataset with just a few lines of code. In this section, we will explore everything from basic plot like bar chart and histogram to more advanced visualization like categorized plot, heatmaps, and so on. You will also learn how to style your plot using Seaborn built-in themes and color plates to make your visualize not only accurate but beautiful. This course is ideal for a student, researcher, professional working in data science, machine learning, and academic research who want to level up their Python visualization skill. So get ready. Open up your Python environment. As we discussed before, Google Colab is our Python environment programming. And let's start visualizing smarter with Seaborn. There is a one point also, all video marked with TA LED means totally designed and reviewed and approved by me, Professor Abolghasem. Of course, you also in this channel, in some courses you will find parallel version personally taught by myself. Enjoy Trueverse channel and have a great time. Thank you.
Hello everyone and welcome back. In this video, we are going to explore various types of distribution plots using Seaborn. These plots help us visualize how data is distributed, which is a crucial step in understanding patterns, trends, and outliers in any dataset. Before we start, I must say that these hands-on exercises are related to the notebook file for the course Artificial Intelligence and Big Data, taught by Professor Abolghasem Sadeghi-Niaraki, Associate Professor in the Department of Computer Science and Engineering at Sejong University. So, let's start. There are several key distribution plots in Seaborn that we'll cover today. The most common ones include the disk plot, join plot, pair plot, ROC plot, and KDE plot. Each of these plots serve a different purpose, and by the end of this session, you'll know how to use them effectively. Let's start by importing Seaborn and enabling inline plotting. We'll also be working in a Jupyter Notebook environment, so we'll be using the Matplotlib inline magic command to display our plots right here in the notebook. First, we import Seaborn. This is the abbreviation for it. And I hit this special command. And there we are. Next, we'll load one of Seaborn's built-in datasets, the famous tips dataset. This dataset contains information about the total bill, tips, and other details from a restaurant. So, tips dataset is this guy. Yep. And give me the head. Here's what the first few rows of our data looks like. We've got columns for the total bill, tips, the day, and other variables. Let's dive into our first plot, the disk plot. This plot shows the distribution of a univariate set of observations. By default, it combines a histogram with a kernel density estimate or KDE, to give us both frequency and smooth distribution curves. So dist plot, which stands for distribution plot, that's exactly what I want. Here we see the distribution of the total bill values from the TIPS dataset. Here we see the distribution of the total bill values from the TIPS dataset. The histogram gives us a sense of the spread of the data, while the KDE layer, here, this line, helps smooth out that distribution curve. If you only want to see the histogram and remove the KDE layer, you can easily do that by setting the KDE parameter to false. Let's also adjust the number of bins to 30 for more detail. Again, a dist plot, and I need a total bill column. Oops, not like this. And well, I don't want the KDE layer. And I also want bins to be 30. Now we've removed the KDE and are left with just the histogram. Increasing the number of bins to 30 gives us a more granular look at how the total bill amounts are distributed. Alright, next up is the joint plot. This plot is perfect when you want to visualize the relationship between two variables, such as the total bill and tip. It allows you to combine two distribution plots and match them up. So Seaborn joint plot, and my first variable is total bill. I don't want to accept this suggestion. I want to type this out myself. The y variable is tip, and the data is, well, tips again. And yep, I want the scatter kind. So here we have a scatter plot showing the relationship between the total bill and tip amounts. The distribution of each variable are shown along the margins of the plot. The joint plot can also take a kind parameter to change the type of the plot. For example, you can create a hex bin plot or even add regression lines. Let's see how that works. Joint plot, total bill. Yep, this is what I want. Oh, it has a T. Yeah, this hex bin plot shows the density of points in each hexadecimal bin, giving us a clearer view of where most of the data lies. And if I say joint plot, X is total bill, this is what I want. No. Data is, no, Y is tip. This one is correct. And I would say kind is, I want to have a regression line. Did I specify data? No. So the data is tips. Oh, against joint. Why did I say join also? Okay, here we added a regression line to the plot. This helps us understand the overall trend between total bill and tip amounts. Now, let's move on to the pair plot. This is an incredibly useful plot when you want to see the pairwise relationships across an entire data frame. It plots the relationship between all numerical columns in the dataset. For example, I can say Seaborn hair plot and pass in the tips dataset. And it might take a while. If I zoom out, yeah, here Seaborn automatically plots pairwise relationships between numerical columns such as total bill, tip, and size. We can see scatter plots and histogram for each combination. The pair plot also allows us to add a categorical variable using the HUE parameter, which can be used to color the plot based on a certain category. Let's try this with the sex column. Seaborn pair plot. I want the tips dataset. Pass in this parameter, and well, this one is good. So now we've used the HUE parameter to separate the data by sex, with different colors representing male and female customers. This gives us a deeper insight into how the data behaves across categories. Next, we'll look up at the ROC plot. This is a very simple plot that adds a dash mark for every point on a univariate distribution. It's often used as a building block for other plots, such as the KDE plot. So in this ROC plot, each dash represents a value in the total bill column. It provides a quick and easy way to see the exact distribution of data points. Finally, let's talk about the KDE plot, or kernel density estimation plot. This is a smooth curve that estimates the distribution of a dataset by placing a normal distribution or Gaussian at each data point. Let's see how the KDE works in a simple example. Here, we'll generate some random data and visualize the basis of a KDE. So we're gonna do this using Matplotlib and NumPy. Import all necessary libraries first. And we also want this one. So our data set is generate a random data set of 25 points from a standard normal distribution, and then create a ROC plot to visualize the data set. We have to determine the minimum and maximum values for the x-axis. So I say x-mean data set mean -2, and the maximum value is data set. I want it to be a little bigger than the minimum and maximum. Right now we have to create an array of 100 evenly spaced points between x-min and x-max, definitely. So which will be our x-axis. Calculate the bandwidth. Okay, what this line is doing, it basically calculates the bandwidth for the kernel density estimation and create an empty list to store the kernel list. Okay, right now a for loop. So calculate the kernel function for the current data point and add the kernel function to the list. Normalize it. Scale it. And finally plot it. Give it a color, I don't know, gray. And then alpha. So it looks good. And the end, a while limitation. Okay, that was too much scaling. Let's make it smaller. Alright, here each small Gaussian curve represents a data point. When we sum these curves, we get a smooth KD plot, which is an estimate of the overall distribution. So the way to do this, we use the sum method from NumPy. And let's give it a beautiful color. An empty list here. Yeah, here you can see the sum of the basis functions. Okay, let's now apply the KD plot to our tips dataset. We'll visualize the distribution of total bill and tips using this plot. KD plot for total bills. A rock plot. And KD plot for tip. Sorry. And a rock plot for as you can see, the KD plot gives us a smooth curve that represents the distribution, and the rock plot adds dash mark for each data point. So this is the KD plot, and this is the rock plot. And there you have it. We've covered a variety of distribution plots. each giving us a different insight into how data is spread. These visualizations are key to better understanding the underlying patterns in your data. Thanks for following along, and I'll see you in the next lesson. Welcome back everyone. In this tutorial, we'll be diving into how to visualize categorical data using Seaborn. Categorical data is one of the most common types you'll encounter, and Seaborn offers multiple ways to explore and understand this kind of data through visualizations. Today, we'll cover various plots such as factor plot, box plot, violin plot, strip plot, swarm plot, bar plot, and count plot. Let's get started. Before we jump into the plots, let's make sure we import Seaborn and set up our plotting environment. If you're working in a Jupyter Notebook or Google Colab, the command Matplotlib inline ensures the plots are displayed directly in the notebook. So import Seaborn as SNC and Matplotlib inline. We'll be working with the tips dataset, which contains information about restaurant bills and tips, along with other categorical features like the day of the week, gender of the person paying, and whether or not they were a smoker. Let's load the data and take a quick look at it. Give me the head. So I can see, as you know, these are the first few rows of our dataset. Let's get started with two basic but powerful plots, bar plot and count plot. These are great for visualizing categorical data in aggregate form. The bar plot allows us to aggregate data based on a categorical feature. By default, it calculates the mean for each category. In this case, for example, we want to compare the average bill for each sex category. So I say from Seaborn, give me the bar plot, my x-axis is going to be 6, and the y is going to total bill. So we will see total bill against each gender, and our data is going to be tips. So because I haven't specified anything, it's actually giving me the mean for each category. So the mean of the total bill for each male category, for each male actually, is 20, around 20, and for females is just a little less. You can customize the aggregation function with the estimator parameter. Now let's change the default function from the mean to the standard deviation using NumPy's std function. First, import NumPy. Again, total bill against gender. Here we change it to standard deviation instead of mean. Now, let's move on to the count plot. This is very similar to bar plot, but instead of aggregating data, it simply counts the number of occurrences in each category. So I use the Seaborn count plot. Again, I want to compare against gender, but since it's a count plot, this will actually count the number of data we have in each gender. So we have around 160 male data and around 80 female data. Next up, we have box plot and violin plot. These plots are excellent for showing the distribution of numerical data based on categorical variables. The box plot is also known as a box and whisker plot. It displays the distribution of data, highlighting the quartiles, the median, and any potential outliers. Let's visualize how the total bill varies across the day of the week. Box plot. Okay, I want to have days of the week in my x-axis, and I want to see the total bill for each day. And well, basically I have to pass in data, which is tips. Here you can pass in a palette, just gives you, a way or a style of your plot. Rainbow will actually be good. This is just a very nice one. So yes, as you can see, we can see all these distribution informations for each day in the week. You can even visualize the entire data frame by setting the orient parameter to edge to change the orientation. So what I'm gonna do, I'm gonna use the box plot. I'm passing the data as tips, and I'm not specifying any specific field. And then I just pass in the palette. Oh, here, say, what was it? Orientation, orient, yeah, the orient. Yeah, this right now looks way better. Box plots can also be used to compare the distribution of another categorical variable. Let's compare total bill across different days and add the smoker category using the HUE parameter. Seaborn, box plot. I want to compare total bill again against the day. And what I want to compare is smoker. So I want to see how being a smoker actually affects the total bill that we have in each day. Yeah, this is very beautiful. I can even pass a palette to this, toolbar. It will just change the colors and styles. So as you can see, we see the distribution in each day again, but this time we have this comparison between being a smoker and not being a smoker for each day of the week. Now, the violin plot is similar to a box plot, but gives more detail by showing the KD, or the kernel density estimate of our distribution. Let's take a look at the same data using a violin plot. So I'm gonna just copy paste this. But here I'm gonna say plot, okay, X and Y will stay the same thing. I will just have to change the palette. I guess that palette would also work, but we want to see it this way with the rainbow. This data is still tips. Yep. Let's just remove this one. See just how it looks at first. Okay, so we can see the violin one, which is a little bit, more beautiful than this one. And it actually looks like a musical instrument. I guess that's why they've named it this way. And what I can do is that I can pass in the HUE parameter, so I can add a little bit of comparison here. So what do we want to compare it? For example, based on sex or gender. So as you can see, it somehow compares how sex actually affects the total bit that we have in each day. And there is this very beautiful argument that I can pass in. I can say split equals true. And this way what it does is that it just sticks these datas together, so we can compare them in a more beautiful way. So let's move on to a scatter plots for categorical data, a strip plot and swarm plot. These are great when you want to show individual data points while still categorizing them. The strip plot creates a scatter plot where one of the axes is categorical. It's particularly useful when you want to visualize all the data points. Let's start with a simple strip plot for total bill across the days of the week. Again, total bill for each day of the week. As you can see, we have our individual data points here for each day of the week. If we look very carefully, we can see where our data is actually centered and where it's a little distributed. We can add a bit of jitter to spread out the points, making them a little easier to distinguish. So, same thing here. Sorry. I can say, how was it spelled? Jitter, I guess double T. So it's just the same data, but right now it's a little bit, easier to distinguish each individual data point. Once again, let's add the HUE parameter to differentiate between male and female using the palette for color. So I can again copy paste this. And give me the same thing, but here compare it between each gender. So it says, yeah, we have the blue data points for male and the orange ones for females. For example, here we see that females have a tendency to have something around 10 to 20 of their total bill on Thursdays, while, for example, male have like more data here, around 20 on Saturday. Now, let's take a look at the swarm plot. This is very similar to the strip plot, but it adjusts the points to avoid overlap, giving a clearer view of the data distribution. Let's plot a swarm plot for total bill across the days. I just want to type this out again. No additional arguments. Let's just see how it works. So, yes. So as you can see, it's the same way we can look at our data, but here they are adjusted in a way that avoids any overlap. We can also pad the HUE parameter again to see the difference between each gender, and well, I can pass in split. What's wrong? Oh, here split is actually Dutch, but it basically does the same thing. It just, puts a little bit of, if I just remove this, let's see what happens. So as you can see right now, these are together, but if I say dodge them, yeah, it puts this little nice space between them so we can see the difference better somehow. It's a matter of personal difference here. You can even combine multiple plots for richer visualizations. For example, let's combine a violin plot and a swarm plot to see the overall distribution and also the individual data points. We use tip as the x-axis and day as our y-axis. So you can have violin plot and I'm gonna copy paste the same thing here. What was the name of the other one? Round plot. The same data, but let's just make it look a little different. I'm gonna pass in the color black, and also I guess it should be spelled with a small b. And let's also pass in the size. So here, as you can see, we have our individual data points inside our violin plot. Lastly, we have factor plot, the most flexible of all categorical plots. It allows you to specify the kind parameter to choose the type of plot you want to display. Let's create a bar plot using factor plot. It's just another way of creating the plot that we've seen so far, but right now their kind is actually passed as an additional parameter to the category plot. So cat stands for category. It can do all our category functions in the same function, and only thing you gotta do is that you have to pass in what kind of visualization you want as this kind argument. So I want a bar plot, so I pass in kind as the bar, and here we have a bar plot. Great job, everyone. Today we explored several types of categorical data plots in Seaborn, from bar plot and count plot for aggregate views to box plot, violin plot, and even combining plots like violin and swarm plot for richer insights. Each of these plots help you better understand and explore categorical data. Thanks for following along, and I'll see you in the next tutorial. Welcome back, everyone. Today we'll be diving into matrix plots using Seaborn. Matrix plots allow us to visualize data as color-encoded matrices, making it easy to identify patterns and clusters within our data. These plots are often used for showing correlations or cluster data. In this tutorial, we'll explore Seaborn's heatmap and cluster map functions. Let's get started. As always, let's first import Seaborn and set up our plotting environment. We'll also use Matplotlib inline command to ensure our plots are displayed normally. And inline. For this tutorial, we'll work with two datasets that Seaborn provides, flights and tips. The tips dataset contains information about restaurant bills and tips, while the flights dataset contains the number of passengers for various months and years. Let's load these datasets and take a quick look at a few rows of them. So flights, Seaborn, load dataset, flights, and tips. So I loaded both of them. Now let's see what we have in tips. Just a few rows. Here we have total bill, the tipping, it's just a normal info that you would find in a restaurant, the sex of the people who've actually tipped or ate something, if they were a smoker or not, the day, the time, and everything else. And let's see what we have in our other data set. So here we have a table, number of passengers, the month, and the year that that flight happened. Okay, let's start by exploring Seaborn's heatmap function. A heatmap is a way of visualizing data in matrix form with colors representing the values in each cell. This makes it easy to identify patterns and relationships in our data. The heatmap works best with data in matrix form. For the tips dataset, we can compute the correlation matrix using the .corr function. This will give us a matrix of the relationships between the numerical columns in our dataset. So, what I actually mean by this, let's import pandas because it's a tool that I'm going to be using right now. So, at first, I'm going to say, let's get dummies from tips and columns. So what this line does, it actually converts the sex column into a numerical representation using the one-hot encoding. So we have this, then I do this. So this line, let me explain it first. It actually converts the smoker column to a numerical representation using the one-hot encoding. And we're basically going to do the same thing for other columns too. For the day column, and at the end, I'm going to do this. Tip size smoker yes, and data day Friday, day Saturday, and finally day Sunday. And at the end, I'm going to tell it to calculate the correlations. So what this line is doing is that I'm telling it to keep only the one-shot encoded columns and the numerical columns. So, and here I'm actually calculating the correlation matrix. So if I run this code, so here we have the correlation between two columns represented as a number between -1 and +1. Now, let's pass this correlation matrix to the heatmap function and visualize it. So what this function does, it's very obvious based on its name. It gives you a heatmap, which is a map like this. This is our first heatmap. Each cell is color-coded according to the correlation value between two variables. Darker shades represent stronger correlations, while lighter shades represent weaker correlations. We can further enhance this heatmap by adding a color map and displaying the actual correlation values inside the cells with annotation equals true. Here we use the cool warm color map, which provides a nice gradient from cool blue for negative correlations to warm red for positive correlations. So, I accidentally rerun the cell. So I have the same thing, but I want to say color mapping here. It's going to be coolvar. And the annotation is going to be true. Now, let's work with the flights dataset. This dataset contains the number of passengers who flew in each month over several years. Before we can plot a heat map, we need to restructure the data into matrix form. We can do this using a pivot table, where the rows represent the month and the columns represent the year, and finally, the values represent the number of our passengers. Pivot table. Passengers. Index is the month, and columns is the year. So our data is right now ready to turn into a heat map. So let's store it in a variable called PV flights. Actually, just going to copy paste this. And right now I can easily convert it to a heat map. So Seaborn heat map. As you can see, the color of each cell represents the number of passengers for a given year and month. Lighter shades indicate higher passenger counts. So for example, we can say, at the year 1960, or around August, we had the highest number of passenger counts. Now, let's enhance this heat map by changing the color map to magma, which provides a more dramatic contrast, and adding line color and light width to separate each cell with a white border. Now let's enhance this heat map by changing the color map to magma, which provides a more dramatic contrast, and adding line color and line width to separate each cell with a white border. The pivot table for our flight, color map, make it magma, and I want a line color here, white. So this means that put some line between my cells and also give it a width. So this is way more understandable right now. Now let's explore the cluster map, which adds clustering to our heat map. This allows us to group similar rows and columns together based on their values. In our case, the rows represent months and the columns represent years, and they'll be clustered based on the number of passengers. So, to create a cluster map, we simply pass our pivot flights data to the cluster map function. Let's see how it looks. Let me zoom out a little. Notice that the rows, which mean months, and columns, which mean years, are no longer in their original order. Instead, they are grouped by similarity in passenger counts. For example, July and August are clustered together, which makes sense because they are peak travel months. To make the information even clearer, we can apply normalization using the standard scale parameter. This standardizes the values, making it easier to compare different cells across the heat map. We'll also use the cool-warm color map for better visual contrast. Zoom in again. So, cluster map. color mapping is going to be cool one. Why is this coming down automatically? What's happening? I don't know. And standard scale is going to be 1. What did I just spelled? So as you can see right now, we have a way cooler color map, and we've also made our scale standard, and it just starts from 0 to 1 right now instead of going from 200 to 600. And that's it for today's lesson on matrix plots. We've explored 2 powerful visualization tools, the heat map for plotting data in matrix form and the cluster map for identifying clusters within the data. These plots are great for identifying patterns, correlations, and relationships in your dataset. In later lessons, we dive even deeper into clustering when we explore machine learning techniques. Thanks for following along, and I'll see you in the next tutorial. Hello everyone. In today's session, we are going to explore grids in Seaborn. Grids are a powerful tool that allow us to create grids of subplots, making it easy to visualize multiple plots separated by different features. We'll cover different grid types, such as pair grid, face grid, and join grid. These are incredibly useful for displaying relationships in complex datasets. Let's get started. To begin, let's import the necessary libraries. We'll be using Seaborn for visualization and Matplotlib to assist with certain plotting functionalities. Seaborn, pyplot, and inline. For our first examples, we'll be working with the iris dataset. This dataset contains information about different species of flowers and their measurements, which is perfect for plotting pairwise relationships. Iris, again, load dataset, iris, and iris head. This is our dataset. We have the species name and some info about them. Let's start by looking at the pair grid. A pair grid is a flexible grid for plotting pairwise relationships across different columns in a dataset. You can map various plot types to this grid and customize it as needed. To begin, we can create a basic grid with Seaborn pair grid. This will just give us an empty grid with no data yet mapped to it. Seaborn pair grid constructor passing the iris. So if I zoom out completely like this, you can see the entire data grid that we have. Now let's map a simple scatter plot to this grid using map. This will add scatter plots to every pairwise combination of our columns. So what we gotta do here, Seaborn iris, and use this map function. If you want to see it completely, as you can see, we have the relationship between each 2 pairs of our columns in the dataset here displayed as data points. One of the strengths of pair grid is the ability to map different types of plots to specific sections of the grid. For example, we can use histograms for the diagonal, scatter plots for the upper triangle, and then kernel density plots for the lower triangle. So we can assign different positions to different data. This is how we can do this. We say Seaborn, we have a per grid, again, from this iris, and then I say map diagonal hist. So this kind of, for example, scatter plot will be in the upper part of the map, and map to the lower part of my grid KD plot. So I'm actually telling it to map different kinds of grids to different parts of my map, of my grid. As you can see, the diagonal here contains histogram, the upper triangle displays scatter plots, and then the lower triangle shows KD plots. This gives us a comprehensive view of the relationships between variables. While pair grid offers a lot of flexibility, sometimes you just want a quick and simple plot of pairwise relationships. For this, Seaborn provides the pair plot function, which is a simplified version of pair grid. So I say Seaborn pair plot, I pass in our data set. As you can see, this automatically generates pairwise plots for the numerical columns in our dataset. If you want to add color to differentiate between categories, such as the species, you can do that by passing the HUE argument. Seaborn pair plot iris species, and I want to give it a different palette. Give me a rainbow palette. So as you can see, with this parameter HUE being passed as a species, we can now easily distinguish between the different flower species using different columns. So for example, we have orange for this species, we have this dark blue for Setosa, and for this one. And we also have different ways to show our data here. Next, let's dive into facet grid, which allows us to create grids of plots based on a feature in our data. For this example, we'll switch to the tips dataset, which contains information about restaurant bills, tips, and other factors. So let's load this dataset first. Tips dataset, and give me its head. So first, let's create a simple grid where we separate the plots by the time of the day, lunch or dinner, and whether the customer was a smoker or not. We can first create the grid structure with seaborn.facetGrid. So this is what I do. I call Seaborn facet grid. I pass in the tips dataset. Column is going to be time, and the row is going to be a smoker. So if I hit run on this, yeah. So as you can see, this is the backbone of our grid. I also want to actually store it in a variable. And okay, now let's map a histogram to each grid. We'll visualize the distribution of the total bill column across each category. I'm gonna say map. So I'm actually changing it and assign a histogram of the total bill column. And there we go. Facet grid also supports additional features, such as adding a hue for color differentiation. Now, let's include the sex column as a hue and use a scatter plot for each grid. So, Seaborn, facet grid, tips, column is going to be time, and the row is going to be smoker. I map a scatter plot of the total bill and a tip function. And at the end, I call Abolghasem. Notice how we've added a third dimension of information by coloring the points based on the sex column. This allows for even richer insights. And that wraps our exploration of grids in Seaborn. We've seen how to use per grid and facet grid to visualize data across multiple dimensions, allowing us to easily compare and understand relationships in complex datasets. Grids are a powerful way to break down your data visually, and I encourage you to explore them in your own projects. Thanks for watching, and I'll see you in the next lesson. Welcome back, everyone. In today's lesson, we'll explore one of Seaborn's powerful tools for visualizing relationship between variables, regression plots. Specifically, we're going to focus on the lmplot function, which allows us to create linear regression plots and split them based on features or categories. This function is quite flexible and is an excellent way to get a quick insight into how two variables might be related. So, let's dive right in and see how it works. First, as always, we'll need to import Seaborn and load our dataset. We'll be working with the familiar tips dataset, which contains information about restaurant bills, tips, and other customer details. So, I import Seaborn again, and I use this command to show my plots inline, and then let's load our dataset. And let's see what it's got. Here's a quick look at the first few rows of our tips dataset. We can see columns like total bill, tip, sex, and a smoker. These variables will be perfect for exploring relationships between different features using regression plots. Now, let's get to the lmplot function. This function is used to create linear regression plots, showing the relationship between two variables along with a fitted regression line. Let's start by plotting a simple regression line between total bill and tip. So I use the Seaborn lmplot function, and I see my x-axis is going to be the total bill variable or the total bill column, and plot tips, and well, we have to also specify our data set. As you can see, Seaborn has automatically generated a scatter plot of total bill against tip, and it has added a regression line to model the relationship between these two variables. This is the basic functionality of the lmplot. Now, things get interesting when we introduce additional features. With lmplot function, we can add a hue parameter to differentiate data points based on a categorical variable. Let's see how this works by adding sex as a category. So I'm just gonna copy paste this one. But this time I'm going to say, okay, we have an additional argument, which is the Huey. So here we've added Huey based on the sex column. This means that the data points are now colored according to whether the customer is male or female, making it easy to visually compare the two groups. By default, Seaborn uses its standard color palette, but we can customize this using the palette argument. For example, we can use a cool warm color palette for better distinction. So again, I'm gonna call the same function, but this time I'm going to say, okay, so I'm gonna use a different palette like cool warm. So the palette is cool warm. Now we've got a more visually appealing plot with blue and red colors representing male and female customers respectively. This helps in making the categories pop out even more. Another great feature of LMplot is the ability to customize the markers for different categories. For instance, we can change the markers for male and female customers. This adds an additional layer of differentiation between the groups. So, imagine I pass in the same function again, but this time I'm going to pass a few additional arguments. For example, I'm going to say that I need new markers. So take this list of markers, 2 characters, O and V, and we should also pass this. Scatter is S and 100. So here we've set circle markers for male customers and triangle markers for female customers. We've also used the scatter KWS argument here to increase the size of the markers to make them more visible. The flexibility of LMplot makes it very easy to customize your visualizations. Seaborn also allows us to create grids of plots based on different categorical features. This is done by using the col and row parameters. Let's create separate plots for each sex category using the col argument. So col as in column. So again, Seaborn and plot. Let me type this out again. We have the total bill. We have tips. Oops, sorry. We're gonna say plot the tip based on the tips data set. And here there is an argument that I can pass in, which is the sex column. So now, as you can see, we have 2 separate regression plots, one for male customers and one for female customers, in 2 different columns. This helps us compare the 2 groups side by side. We can take this even further by adding both col and row parameters to create a grid of plots. Let's separate by both sex and time, lunch or dinner. So then plot total bill, the relation between total bill and the tip again. Data is going to be tips. And here I can pass in a row and a column together. So this way it gives me a table. If I zoom out, now we have 4 separate plots, one for each combination of sex and time. Here we have being a female and lunch, being a female and dinner, male and lunch, and male and dinner. This makes it easy to analyze the relationships within each subgroup. We can combine multiple features by using both the hue argument and grid columns. let's plot the regression by separating the data by day using column and coloring by sex with HUE or hue. Seaborn, plot. Okay. The total bill, again, Y is going to be tip. Data is going to be the tips data set. Separate in columns based on the day, and also give me some coloring based on the gender. And I can even change the color palette again. So we use everything together. It says palette is misspelled again. I don't know why I always write it like this. So there we have it. This creates separate plots for each day of the week with different colors representing male and female customers. This way, we can see how the relationship between total bill and tip varies across days and genders. If your plots are looking cramped or too wide, Seaborn allows you to adjust the size and aspect ratio of the plot. You can do this using the size and aspect parameters. Let's make the plots taller and adjust their aspect ratio. Let's zoom in again a little. Seaborn, lamp plot, total bill, tip, and again our data is tips. I want to separate by the day of the week in each of my columns. Again, pass this guy too. I'm gonna color them by their gender. A new palette. And this time, what I actually want to do is that I want to change the aspect ratio. So I want to say the aspect ratio is this guy, and change the size to change the height of my plot. Let's see what it does. So now the plots are taller with a reduced aspect ratio, making them easier to view. This is particularly helpful when working with a lot of subplots or grids. That wraps up our lesson on regression plots using LMplot. We've explored how to create basic regression plots, customize markers, and use grids to separate data by categorical features. Seaborn's LMplot is a powerful tool for quickly visualizing relationships between variables and uncovering trends in your data. Thanks for watching, and don't forget to check out the style and color lecture for more tips on customizing your plots. See you next time. Hello everyone, and welcome to this video on style and color in Seaborn. In previous lessons, we've touched on some ways to adjust the look and feel of Seaborn plots. But now it's time to formally explore how we can control figure aesthetics. This includes setting styles, managing plot size, removing plot spines, and more. Let's get started. First, we'll need to import Seaborn and Matplotlib, and we'll load the familiar tips dataset, which contains information about restaurant bills and tips. So I'm going to import Seaborn. Then I will import pyplot from Matplotlib and inline command, and let's also load the tips dataset. With the database loaded, let's begin by exploring how we can set different styles for our plots. Seaborn allows us to easily set different plot styles using the setStyle function. Let's start with the default count plot showing the number of males and females in the tip dataset. Seaborn, a count plot, and okay, so we have something around 160 male and something about 80 female in there. And this is the basic Seaborn style, which includes grid lines and a default color palette. But we can quickly change this by setting a different style. Let's use white, which removes the grid lines. So I can say Seaborn set a style white, and then I'm going to plot this count plot. So as you can see, the grid lines here, they have actually been removed. Let's try another style, ticks. This style adds tick marks to the X's, which can give the plot a more polished look. Seaborn, set a style, ticks. And just plot the same count plot. 6, data is tips, and palette. I'm just going to give it a new palette. So you see the color difference too. So here you can see that we have these cool marks in here on our x-axis, and also notice how we've also applied the deep palette for a different color scheme right in here. This style with tick marks and deeper colors gives the plot a more refined look. Sometimes we may want to remove some or all of the plot spines, which mean the borders along the sides of the plot. Seaborn has a simple function called dspine that allows us to do this. Let's start with the basic plot again. Seaborn count plot. This is our basic plot. Let's just see how it looks again. Okay. Now, if we call dspine, it will remove the top and right spines by default, creating a cleaner look. So right here, if I say Seaborn dspine, as you can see, the right spine is removed. If you want to remove only one specific spine, you can do that too. For instance, let's remove just the left spine. So here, I can pass in an argument as say left is true. Now the left spine is gone as well, leaving us with only the bottom spine. This feature is perfect for making plots look less cluttered and more modern. Next, let's talk about controlling the size and aspect ratio of our plots. With Seaborn, you can use Matplotlib's plot.figure function to adjust the figure size for non-grid plots. Let's make a wide horizontal plot by specifying the figure size. So from Matplotlib, we can use a figure and give it a size. And then what we do is that we call Seaborn and call count plot with this guy. Here we've set the plot to be 12 units wide and 3 units tall, giving us a long and narrow view of our data. For grid type plots, such as LM plot, you can adjust the size and aspect ratio directly with Seaborn's size and aspect parameters. Let's make an LM plot with a smaller size and a stretch aspect ratio. Seaborn LM plot, total bill, y is tipped, and height is 2, aspect can be set directly, and again data is going to be tips. Here the plot is stretched horizontally with an aspect ratio of 4, while the size is set to 2 units. This flexibility allows you to fine-tune the plot dimensions to suit your needs. Another powerful feature in Seaborn is the ability to scale the entire plot using set context. This is particularly useful when you want to adjust the visual scale for presentations, reports, or posters. Now, let's create a larger plot by setting the context to poster, which makes everything bigger, both the plot size and the font size. Seaborn set context function, and I want to pass in poster here, and font scale is 4, and then we have Seaborn count plot. Again, I want to have a count plot based on gender from the tips dataset, and let's also give it a custom palette. I love this cool warm palette, so I'm going to use it again. And now, as you can see, everything is scaled up, making it perfect for a presentation or poster format. Not actually suitable for your browser because, as you can see, well, it's not really readable here. The font scale parameter here, it actually adjusts the text size, making it easier to read. For example, I can pass this to 1. So yeah, this is right now better for my browser. So I also want to add a final note in here. If you'd like to learn more about these styling options and other features, Seaborn's documentation is an excellent resource. Here's a link to the official documentation page where you can find more details on plot aesthetics and customizations. Feel free to explore different style settings and customize your plots based on your needs. With Seaborn, there's almost no limit to how you can tweak your visualizations to make them both informative and visually appealing. And that's it for this lesson on style and color in Seaborn. You've seen how to set different plot styles, remove spines, adjust plot sizes, and scale figures for different contexts. These tools are essential for making your data visualizations both clean and impactful. Thanks for watching, and don't forget to practice these styling techniques in your own visualizations. See you next time.